Good afternoon, dear colleagues. I am Dmitrii Kovalenko. I work in MSK-IX. I will be talking about some tests that we use in our infrastructure. MSK-IX, it's not only Internet exchange, but DNS service provider in infrastructure which there is top-level domains, and it increases the requirements to the DDoS. We use continuous monitoring, regular testing, service audit, and we will be talking about this in details. About any cost, it's a balance in the network level, GDP protocols. The slide shows the typical cloud DNS any cost. Every cloud contains of different nodes. The main service is DNS, but there are some accessory services, monitoring, statistics, analytics. A few words about MSK-IX DNS cloud. We use 10 Anycast clouds. They are geographically distributed. They are in the regions of Europe, the USA, Asia, in the Russian Federation, and some clouds for Moscow and St. Petersburg that are supported by IPv4, IPv6, DNSSEX, and more than one AS. When we operate a large number of servers, there is a question how to embrace all the services as to the Anycast server address. To use the customary model when we look from one point and we can see the nearest node as to GMP, how to evaluate whether or not these other nodes are work or not as to the service address. It's a typical issue to look what kind of system to use of probes and to use distributed monitoring consisting of different probes. In this way, some known system like RIPE, Atlas, and other system can help us. It's a very interesting problems with the RF coverage. When we start monitoring using alien infrastructure, the question is what kind of application to monitor, whether or not it's included into the list of well-known protocols and applications that this or that system allows to use, whether or not we need the infrastructure control or not. Like the previous presenter said, sometimes there are interesting specific features of probe behavior, whether or not we confined in the measurements that happened, because there may be the problems at the last mile or some actions are from the owner of the probe. Probe is switched or probe is moved in the other place. We use nodes for our infrastructure monitoring. Every node has the probe with the external address and not only IPv4 and IPv6. The contact with the Internet service provider can help us to solve the problems outside of our responsibility zone. Our internal measurements, so we add to this RIPE Atlas, and everything gets into the system of monitoring where the analytics and calculations are conducted. DNS cloud monitoring is only part of our system monitoring, several tiered DNS service control domain zones, availability of distribution servers. Every node is controlled by unicast addresses, the parameters of the servers, network equipment, and external internal channels. When there is a system of monitoring, it's very interesting to define the threshold of the software and network infrastructure. These structures, they are for monitoring. We do testing of different software that we can use in our infrastructure. Quite recently, we conducted the comparative loading test, bind NSD. The task was to find with the series of stress tests the maximum production capacity of every package at the certain platform. Maximum production capacity. We looked at this. If a certain amount of DNS queries came, it's very important so that to receive the similar amount of responses in the backflow. We build up the testing stand that consists of two servers and one commutator with two control points. We tested subscribed zone. The important fact that the sizes of packages several times larger than the very queries. During the calibration, we had to increase the physical capacities, first of all up to aggregates of 2 ports, and then we switched to the 10 gigabit port. While during the tuning of the stands, we used on the generator such software as Query++ and DNS Perf, but we did the best in Spirit Play and support of peer map. As to the server, we had the Byte and ENSD software. As to the methodology and the results, the methods is the following. We take analog of the root zone that is subscribed and consists of several millions of records, NS, AAA, and PRSIG, and others. During several hours, we collected the queries and we played them on our stand. The results you can see on the table. Quite interesting conclusion can be made. While receiving the load more than 200,000 packages per second, if the node consisting of several servers or the very server that can serve this flow, it will require a bandwidth not less than 1 gigabit in second to deliver the response to the client. This test, the result of this test, it's the result of this test. The next test, apart from the outcoming bandwidth, we had the problems with the incoming bandwidth that is not dependent on the server. Any UDP, ECP, and other flood may come that will occupied their incoming bandwidth, and something is to be done. We use the internet providers that provide their security protection from DDoS. We do testing. For this, in the node, we have the test server that is designed for conduction of these tests. We have the test unicast network. The traffic of this network is bound to the certain server, and then it's announced by the provider. As a rule, to the means that provide a technical means to suppress DDoS, there are no questions. The goal of this stress test is to work out the liaison with the other stakeholders and to work out template to suppress the typical threats and DDoS. For this, on the slide, there is a certain kind of a server that we use Spirit Play to play real fixed detected attacks and to generate a kind of tests about the methods and the results. Let's talk about this. The load test or stress test is consists of 3 parts. The first, it's tuning part, the second we calibrate, and the third part we check. First of all, we send a synthetic bed flow not exceeding the set bed widths, and it should be filtered with our own filters. We send the traffic to the address with the port that is filtered on the router. Then we compare with the checklist, and we can see that the announcement came. It may be an email or maybe a call. We check that we need the task for mitigation in the account of the carriage operator. We compare all this with the probe in the system of monitoring and check that the loading went with upstream. On our route, we don't have this incoming traffic. If everything is okay, we shift to the second part of the test. At this point, we send bed flows that initially were prepared with to the server ports of the test address. Here we compare with our checklist, and then at the end we see according to speeds whether or not these flows came to the test server. If they didn't come to test server, we go to the test stage. We send bad flows to activate the certain protection template, and we send good flows initially prepared, and compare how many responses came, how many responses didn't come, and which ones were casted away. As a result, we get a good liaison activity with the technical service, with the operator. We get the understanding that we are protected from DDoS, and we calibrate the protection template from the typical threats. It can minimize the reaction time when the problem arises. Problem related to DDoS or loading of the circuits. Conclusions. The main part is finished. We have the geographically distributed unicast. We are available for peering. We have the clients. If you have the clients in the geographical locations together with you, we are ready to initiate peeling, to conduct GPR section for monitoring of different places and with different systems. We can say about the certain level of service, the compliance with SLA, the regular stress test of the infrastructure, network infrastructure increase our reliability from denial attacks. Thank you. Questions? Good afternoon, dear colleagues. Alexei Kuzin, DDoSR company. What is the volumetry of these tests? Volumetry of these tests. What is volumetry of these tests? Can you rephrase the amplitude, the volume of traffic? Not to make harm to ourselves, we check first on some servers that carries the working traffic. We restrict the bandwidth, and during the first stage, when we evaluate the interaction, we are talking about 20, 30 megabits of incoming traffic. The most important part, we should see this on our equipment, and later on, while switching on the protection template, we should make sure that we have the conventional loading of traffic on our equipment, and then we can launch the traffic of higher volume, but you should understand the test server is connected with the operator, carriage operator, and of course we are talking about money. Of course, you are not talking about 100 megabit, maximum several hundreds megabit.
So that's comforting you, right? Dozens of gigabits. It's sufficient, it's enough. As I mentioned before, we trust the means that are used by internet providers. Are you using ABBA? But according to the slide that you showed us, no, we are not using it. But our operators, network operators, are using that. Of course, in this context, I'm asking you, it is a unilateral connection between parties. IRA2, we used to have it, and some other Russian companies. So different vendors of different equipment. Yes, we have an access to the metrics in the interface, and we work with this data available for us. Dmitrii, as far as I understood, you are provided by your partners with all the perimeter and the volume of your work. Have you considered working more independently with a shorter system with a smaller number of layers? Theoretically, it can be done, but it will require more time, more resources, human resources, and we need to set some other tasks. But theoretically, it can be done. But practically speaking, if there is such a need to use the groundwork in practice, it is easier to be done with the help of network operator because they are specializing in it. So you not have internal expertise. That's why you outsource it. Is that right? Well, we have our internal expertise, but sometimes we need a more profound level of expertise. Then we outsource. Okay, thank you. Pavel Kolesnikov from Huawei. I have a question, like an intimate question. You can answer it or not, as you wish. Do you have any statistics about real DDoS attacks so you've protected yourself from? So how great is the threat? Yes, of course, there is some threat, and we do face some attacks, and somebody is helping us. Yes, thank you. I have a question from me. What is the volume of those attacks? It is related to the question that has been previously asked about the volume and the amplitude. What is the volume of the attacks that you are facing? Oh, different. Maximum, can you name us? Several hundreds of megabits. More than 100. Yes, we do have such situations. If we do not have any more questions, I'm passing the floor to Anton. Thank you very much for your speech.